Hello everyone, this is Sahana Kulkarni. Again in this session we are going to discuss the continued part of moving charges and magnetism, that is in session 8. So first of all, in this session we will discuss regarding the moving coil galvanometer. Already we know galvanometer, which is a device which is used to detect or measure a very small amount of current which is flowing through an electronic circuit. So generally galvanometer or moving coil galvanometer both are same. That is, moving coil galvanometer, it is a device which is used to detect a small amount of current which is flowing through the circuit. So in what principle the moving coil galvanometer that will works? That is, when a current which is carrying a loop that is placed in an uniform magnetic field, then it will experiences a mechanical force, that is nothing but the torque. So the main principle of the galvanometer is the torque. So because of torque, the galvanometer will starts to work. Then what is the construction of this galvanometer? That is, it consists of one rectangular coil having a number of turns of copper wire. They are wounded over a non-magnetical material frame which is suspended with the help of a bronze wire between two north as well as south strong poles of permanent magnet, and the suspension which is attached to the toroidal head. Similarly, the other end of the coil that will be connected to the spring and the further to the outer circuit, a small mirror which is attached above the coil, and the soft iron that is placed inside the frame, that is shown in the diagram. So in the diagram, just you can observe one pointer is there, the scale, and the permanent magnets, that is north and south pole magnets are there, and the coil, the rectangular coil which is having n number of turns, that is also used here, which is made up of the copper wire, and the soft iron core that is also placed in between the strong poles. So this is regarding the construction of the galvanometer. Then how it will be working? That is, in the absence of the current through the coil comes to the rest condition because there will be no current is flowing. Therefore, the coil will not start to rotate. Therefore, it will be in the rest position. When a current passes through the coil, it experiences a torque, or we call it as it is an anti-parallel force. With the help of this torque, then it starts to rotate the coil till the torque as well as the restoring force becomes equal. So whenever the current is passes through the coil, the torque will be produced, and with the help of the torque, that entire rectangular loop starts to rotate, and this rotation will be taken place up to what the torque as well as the restoring forces becomes equal, and which produce a twist in the suspension wire. So as soon as the current stops flowing through the coil, the restoring force rotates and the coil and produce certain oscillation here. Therefore, the theory behind the moving coil galvanometer, therefore we can say, let n be the number of turns in the coil, L and B, these are the length and the breadth of that rectangular loop, and B, capital B, is the magnetic field in which the coil has to rotate. When a current I that is passed through the coil, of course it will experiences a torque, or we can say a rotating couple or the deflection couple. So because of the torque, it will start to rotate, that is we can call it as it is a rotating couple or deflecting couple, and that torque will be given by, thus the torque is equal to, already we know it is force into the perpendicular distance. Therefore the deflecting couple, therefore we can mention it as a CD, that is a deflecting couple. So CD is equal to force F as it is into the perpendicular distance is nothing but the breadth here. Therefore CD is equal to, already F we have calculated in the previous class itself, that is NBIL into this B. Then but area of that rectangular loop is nothing but length into breadth. Therefore our CD deflecting couple is equal to NBIA. Instead of length into breadth, we have substituted it as area. Therefore, CD is equal to NBIA. Then the deflection which causes the twist in the suspension and the spring, thus the restoring couple that will be produced. Therefore, that restoring couple that will be denoted as CR, and that CR is equal to C theta, and it must be equal to the deflecting couple. So both the couples, deflecting couple as well as restoring couple, whenever they will become equal, then we can get the twist in the suspension in the spring. Therefore, CD is equal to CR, that is deflecting couple is equal to the restoring couple. That implies CD already we have calculated, it is NBIA, that equal to CR. CR is nothing but it is C into theta. From this, the current I is equal to, we can write it as C divided by NBA into theta, or we can write it as it is I is equal to K into theta, where K is equal to, it is C divided by NBA, and it is a constant, and this constant is known as the reduction factor of the galvanometer. Therefore, we can say I is directly proportional to theta, means when the current through the coil that is directly proportional to the deflection in the coil. So how much amount of current is flowing, that much amount of deflection we are getting. Therefore, theta, it is the measure of the current through the coil. Then we can define one more definition, that is current sensitivity. So current sensitivity, it is defined as the deflection produced in the galvanometer when a unit current flows through it. So therefore, current sensitivity IS is equal to, it is a deflection divided by the unit current, that is I. So theta divided by I. Theta already we know it is NABI divided by C whole divided by I we are getting. So I get cancels, we are getting it as NAB divided by C, and the unit of current sensitivity is radian, because theta is measured in radian and the current is in ampere. Therefore, it is radian per ampere. And similarly, one more definition, that is voltage sensitivity. So voltage sensitivity, again it is defined as the deflection produced in the galvanometer when a unit potential difference or a unit voltage which is applied across the two terminals of the galvanometer. So current sensitivity means when a unit current flows through it, but what a voltage sensitivity means when a 1 volt or unit voltage which is applied through the across the two terminals of the galvanometer. Therefore, voltage sensitivity is equal to, that is Vs is equal to theta divided by V. Theta is again it is NABI divided by C whole divided by V. But instead of V, we have substituted it as, according to the Ohm's law, V is equal to IR. So that value IR we have substituted. So again I get cancelled, we are getting it as NAB divided by CR. That we can write it as it is NAB divided by C is nothing but our IS, that is current sensitivity. Therefore, it is IS divided by R, and the unit is again theta is in radian voltage, that is per volt. Therefore, it is radian per volt. Next, we will discuss regarding the pointer galvanometer. So pointer galvanometer, it is a modified form of suspended coil galvanometer. The main disadvantage of suspended coil galvanometer is it is not at all portable. So in pointer galvanometer, the coil is pivoted between the two bearings, and the advantage of pointer galvanometer is that of portable as well as it is a compact. This is one more type of a galvanometer like our moving coil galvanometer. So only the difference is the pointer galvanometer is very handy, as you can say it is portable, and the compact one as compared to the moving coil galvanometer. Then we will discuss one more important concept in this chapter, that is conversion of galvanometer into an ammeter. So how we are going to convert the galvanometer into as an ammeter? Therefore, a galvanometer that will be converted into an ammeter by connecting a suitable low resistance in parallel to the coil or in parallel to the galvanometer. And the low resistance across the galvanometer, that low resistance itself is called as it is a shunt resistance. Therefore, just you can observe the circuit diagram here. that is galvanometer G, and S is the low resistance that will be applied, and both are connected in parallel. So when both are connected in parallel, then our galvanometer will be converted into an ammeter. Therefore, we can calculate the further derivation regarding this. Ig, that Ig is nothing but it is current which is required to produce the full scale deflection in the galvanometer, and capital G is the galvanometer resistance. To calculate how much amount of low resistance which is required to connect parallelly, that is potential difference across S must be equal to the potential difference across G. Therefore, potential difference across S, that is we can write it as it is I minus Ig into S, that is equal to potential difference across G is Ig into G. Therefore, we can write it as multiply the S term, that is Is minus Igs is equal to Igg. Therefore, Is is equal to Ig is common, take it out, and S plus G we are getting. Therefore, from this, what is Ig, the current produced to get the full scale current through the galvanometer, that Ig is equal to, it is S divided by G plus S into I, or we can write it as Ig is directly proportional to I. Now, we can discuss one more concept, that is conversion of galvanometer into an voltmeter. So, how to convert the galvanometer as an voltmeter? That is a galvanometer that will be converted into voltmeter by connecting a suitable high resistance in series with a galvanometer. Don't get confused with these two. Whenever we are going to convert the galvanometer into ammeter, at that time we have to connect a very low resistance parallel to the galvanometer, and when we are going to convert the galvanometer into voltmeter, at that time a very high resistance we have to connect series with a galvanometer. We can observe the diagram here. The G is the galvanometer, and in series R, that is a resistance we have connected, that is suitable high resistance. So from this, V is equal to IR form we know. So therefore, V is equal to I is replaced by Ig, that is current through the galvanometer. Similarly, R is nothing but the resistance. Therefore, here the galvanometer is also having the resistance. So instead of V is equal to IR, we are getting V is equal to Ig. Instead of R, we can write it as it is R plus G. Therefore, R plus G is equal to, we can write it as it is V by Ig. From this R, how much high resistance which is required? Therefore, R is equal to, it is V by Ig minus G. So, from this we can calculate how much high resistance which is connected series with a galvanometer, then our galvanometer will be converted into ammeter. So, these two concepts are very important, that is conversion of galvanometer into voltmeter as well as ammeter. And here it completes the chapter moving charges and magnetism. Just go through the video